Good afternoon. We look at chain rule. Now, for chain rule, remember we are still on partial differentiation. Partial differentiation. For chain rule, there are some functions. Let's look at z being equal to f of x, y, where x is a function of t and y is also a function of t. Now, we can see that when we replace x and y by their respective functions of t, z becomes a function of t. So we can look for the z dt, and the z dt is going to be, we differentiate f partially with respect to x multiplied by the x dt plus we differentiate f partially with respect to y and differentiate y with respect to t. Now this will give us the z dt. We take an example. If z is equal to x e x y and x is t squared whilst y is equal to t to the power minus 1, then we could be asked to find the z dt. Now remember, since z depends on t and y also depends on t, or since x is a function of t, y is a function of t, when we replace x and t by their respective t functions, z becomes a function of t and is a function of only one variable. That's why we say the z dt. And we saw that this is just differentiating z partially with respect to x and the x dt plus differentiating y z partially with respect to y dy dt. So we need del z del x, del z del y, dx dt and dy dt. We replace them there and we are fine. So del z del x is, now here we use product rule because x is here and x is there, right? So we hold x constant, differentiate ex y with respect to x, and I'm going to get ex y. The top with respect to x, I get y, it multiplies. Plus, I now hold exy constant and differentiate x with respect to x, and I get 1. So I get exy. Okay. Next, I find the z, del z, del y. And because there is no y in front here, it becomes, the x is a constant, right? We differentiate this one here with respect to y, and I have x squared ex y. Remember, the top will give me y, x. When I differentiate ex y with respect to y, I get the same function ex y, and differentiate the top with respect to y, it becomes x, it becomes multiplied. Next, I find the x dt and the x dt. I have 2t dy dt. I'll get minus t minus 2. That is that. So next, I just got to replace them where they are supposed to be, and I am okay. So let me put it on top. Let me clean this. So the z dt is equal to del z del x, which is yx exy plus exy multiplying, you can't see at the top, sorry. The z is equal to del s del z, which is yx exy plus exy. The z dt is 2t plus the z dy, which is s squared exy times dy dt, which is minus 1 over t squared. Now the rest is simplification. We simplify. Okay. I can write this as I factorize exy out here. I have exy y times yx multiplying 2t minus s squared exy over t squared. This is equal to dz. But we know that x is equal to t squared and y is equal to t to the power minus 1. So we put these here, and I have in place of x I put t squared times in place of y I put t to the power minus 1. This here is wrong, forgive me. Forgive me. So it's actually yx plus 1 multiplying 2t. When I factorize it out, I get this. Forgive me. So this one is done. Nice. And into bracket, in place of y, I put t to the power minus 1. In place of x, I put x t squared plus 1 times 2t minus, in place of x, I put t to the power 4 t squared times t to the power minus 1 all over t squared. Okay. So the z dt, this will cancel that, and I'll get e to the power t. It will still cancel, okay? And I'll get c plus 1 multiplying 2t minus, this will cancel that, I get t squared, and I have here e t. Alright, we just simplify this and we are fine. Okay, we can let this one multiply through to get et multiplying 2t squared plus 2t minus t squared e t. The rest is simplification. Okay. And we are okay. And we are okay. We take another example. If z is equal to if z is equal to x squared y to the power 3 plus y cos x, but x is equal to the ln of t squared and y is equal to sine 4t. Here we have to find the z dt, which we know is equal to this del z del x dx dt plus del z del y dy dt. So I find del z del x dx dt, del z del y, and dy what? Dt. Del z del x is equal to, if I differentiate with respect to x, I'm going to get 2x y cubed minus y sine x. Del z del y, I'm going to get 3x squared y squared plus cos x. Next, let me clean this one. Next, I find dx dt. When I differentiate those with respect to that, I'm going to get 1 over t squared times 2t, and dy dt will give me 4 cos 4t. Now, you must learn differentiation. You can see that when I reach the differentiation, I do it quickly. I also waste my time, right? Learn differentiation. If you're having problems and you call me, you can go through. Okay. Good. Now we just replace and we are fine. Okay, we just replace. So I'll clean this and I'll do it there on top. Okay, so dx dt now is del x del that is 2x y3 minus y sine x. Dx dt you know, there this will cancel that, and I'll get 2 over t plus del z del y is 3x squared y squared plus cos x, and dy dt I have 4 cos 4t. Now here, what we do is that we have finished solving the question. In place of yx, we said yx is equal to ln t squared and y is equal to cos 4t. In place of x and y, we put these there and we are through. Now this is what we term as chain rule, case 1. This is the case 1. Now we go ahead and look at case 2.